एक मिनट सर फिर से.
Today's experiment we are going to deal with the Wein bridge oscillator. So it's your experiment number 10. So this is your oscillator giving input DC supply of 20 volts and getting AC signal, AC output signal. For Wein bridge oscillator, the output signal should be approximately 15K to 17K. So giving DC as signal, DC input, and getting AC output signal. So it should satisfy the Bark-Hassan criteria. Bark-Hassan criteria. It has two conditions. One is mod of A beta should be equal to 1. So your mod of signal is nothing but your AC signal should be equal to A beta should be equal to 1. And it should be around the loop 0 degree or 360 degrees. Now let us look at the circuit diagram of Wein bridge oscillator. This is your Wein bridge oscillator circuit diagram. This is your R1 which is connected with series of your 1 kpf. This is R2 10k ohm which is parallelly connected of 1 kpf. This is R3 and R4. Now look at this R4, R3 and R4 is one point which is connected to the emitter of your first stage of your transistor. 100 kilo ohm, this is your biasing resistor, this is RC 8.2 kilo ohm, this is your coupling capacitor from this stage of your transistor to the next stage of your transistor. 100k 1.R1, this is your 100k biasing resistor 8.2, 1k 8.2k, this is your bypass capacitor, this is your 10 microfarad which is going to connect it to the output. This output signal should be fed back to the Wein bridge, to the node of R1 and R3, and this R3 and R4 is connected to the emitter, and this node R1 and R2, these are R1 and C1 is capacitor is in series, and this R2 and C2 is in parallel. This node should be connected to the base of this transistor, Now let us look at the circuit diagram which is connected on breadboard. This is your DC input supply which is giving 20 volts. The positive is connected at here and negative at the ground. This is your R1 and C1. This is R2 and C1 which is in parallel, which is connected to the node of the R1 and C1. And this point, this is your R3 and this is your R4. This is R3 and R4. And this node is connected to the emitter of this transistor. And this base is connected to the 100 kilo ohm which is connected from this node. And this is your transistor 1 and this is a transistor 2, and in between two transistors there is a coupling capacitor, and this is your 100 kilo ohm and this is your 1 kilo ohm. This is emitter, this is bypass capacitor is there, and this is your collector where you are going to take your coupling capacitor and output, and this is your feedback which you are with your jumper and being connected from output to the input, and you are from your CRO channel 1 which I was giving positive across my output across your coupling capacitor 1, and another one is negative. Now look at this waveform, the waveform which you got. This is your channel 1 which is connected. So this is your time period which is 0.1 millisecond, and your 1 volts of peak to peak amplitude, 1 volts peak to peak amplitude. Now let us look at calculations what we had it at here. So this is when you look at this is approximately 0.6 of your time period. This is your 0.6 of your time period. Let's calculate 0.6 into 0.1. So we got it this is in millisecond. 0.6 into 0.1 millisecond. So let us keep 1 divided by answer 16 into 10 to the power of 3. So 16K is your 16.6 kilo is your frequency of Wein bridge oscillator. Giving DC as signal, and you got 16.6 kilohertz of your frequency.